Hello there, another in-depth look at remove duplicates. So this time we will be doing the remove duplicate portion as we have done the merge part earlier. In this part of the problem, we'll be doing this part in the lead code, and let's check it out. So here we go. So this is delete duplicates, and let's do the UMPIRE method. We're going to understand it. And the problem is, whenever we see duplicates, we're going to remove the whole entire chain. And this is basically one of the examples. And what would be a edge case in this? It would be 0 items or 300 items. Of course, we're not going to do 300 items. The values are not a matter. So let's ask some questions, right? Minimum is 0 nodes, and max is equal to 300 nodes. That's the relevant information. And with that, we are ready to go. Everything starts, we start with sorted list. And the time constraint is going to be O of n, because we just have to go through the entire list, and space is going to be O of 1 because, well, we're just using pointers. So let's do a match, and the match is going to be either, well, with a linked list, it's best to use a recursion. I think we're going to do a iterative loop and a recursion with pointers. Okay, let's look at our plan. Our plan is to create these nodes, and what we're going to do with this plan is that we're going to iterate how we're going to iterate through these items, right? So one way is the recursive method. If we see that the item next to this item is different, we just move head equals head dot next, and we check the next item. Okay, if it is different, then we keep on moving it forward and just returning the next head. If it is different, we'll move this head until it's no longer the same, and we point our item, our head, to the duplicate of this item, and this will check it and remove everything, and we'll get to the end. Of course, that doesn't make too much sense right now because it's recursion and we're doing it in an iterative fashion. Of course, we'll do it a little bit later with the recursive code, and I think it will make a little bit more sense. Otherwise, we're going to do this recursively, because if we do it recursively, we do need a previous and a current node, and this way we can check if the previous is going to be equal to the current. If it is equal to the current, then we just move everything, shift everything forward. Okay, so they're different, we'll shift it forward. Yeah, so previous dot next here and current dot next. So if previous dot next and current dot next, if these are the same, that means that we have duplicates, and that means we need to move the current forward. And until they're not the same, the current dot next is not the same, that way we can point the previous to the current dot next. Okay, so let's write that down before we forget. So create previous and current pointers. If previous dot next dot val is equal to current dot next dot val, then shift current until current.next does not equal previous .next.val. So this is basically a while loop. Then we can point the previous to the next item. And with that, that's our plan. For the recursive, we just need to make sure that we need to point the head to head.next if head and head.next are different. Otherwise, shift head.next to head.next until head does not equal head.next, and point to the recursive case of head.next. Okay. I think that we're good with the 2 lines of code, the plan, and let's implement as we run out of space. So we'll just, type up here. Okay, so we're going to do the first iterative, and then we're going to do the recursive, and we'll have 2, pieces of code for you. So the first piece of code, let's check it out. So previous pointer, current pointer. And that's going to be equal to the head and head.next. One thing we do need to note is that with the previous pointer, we do need a dummy node, because this could be, the first item could be a duplicate, right? That's this situation here. This is the other edge case right here. Okay, so we do need to do dummy head equals previous equals list node. Dummy head dot next is equal to the head, and now the current is equal to the head. Okay, I think we're good. All right, so yeah, everything looks fine. So we're done with our first line, and the second line is, so while exist, we're going to shift this all the way down. So while current dot next exists, and current previous dot next dot val is equal to current dot next dot val, we're going to shift current equals current dot next. So then if previous dot next does not equal current, well, we could say, yeah, if it is equal, then we'll just set previous equals previous dot next. Else it's different, so previous dot next is equal to current dot next. We'll skip it. and of course current equals current.next, and that's it. That is all the code we need. We just read dummy head dot next. Yeah, or we just, yeah, that's all. Okay, let's see if the code works. All right, so let's run this edge case, and let's just do what we need to do. So we have a dummy head pointing to a 1, a 1, and a 1, and a 2, and a 3. So we have our previous pointer, we have our current pointer, we have previous.next, perfect, and we have current.next. And as you can see here, let's see our first line of code. Current exists, current.next exists. So let's check the values. Previous.next is equal to current value.next. So current equals current.next. So we shift it again. And now current.next is no longer equal. And so we exit this loop and we check if previous.next is equal to current. So previous.next does not equal current. They're different items. So basically this means that the previous.next, what we need to point to, is going to be 2. So essentially this is exactly what happens. We set it to 2 and we delete all of this. So dummy now points to 2. Okay. Of course, current is equal to current.next, which is currently at 2, and we will send it to 2. And we go in for another loop. Current still exists, perfect. And what happens here is that we point is 2 is previous.next equal to current.next. No, they're not equal. So we skip that and we just do previous.next is equal to current. Yes, they are equal. So basically that means we can shift the previous forward. We have one unique item. Now we shift the current forward, we do the same operation. Of course, current.next is equal to nothing. We basically skip this operation here and we just set previous to previous.next. So we shift it forward, we get another item, and now we are done as current reaches the end and we have returned 2 and 3, which is our predicted output. So with that, let's do an evaluation on that code. And that's going to be, so the time is going to be O of n because we went through all the items. And the space was O of 1 space as we predicted because we only used pointers. So let's run the code, make sure it works. Of course, it does work. And let's submit. All right, great. All right, we have a nice solution here. What we're going to do next is the recursive. So implement the iterative. And now we're going to implement the recursive. All right, so how are we going to do this? Pretty simple. So what happens if not head or head.next is equal to none? Well, basically return the head. And there's basically return the item. And how are we going to do this? As I said earlier, we have head here, and this is our plan. So recursively point to the head if they're different. So recursively point head to head.next if the heads are different. So while head dot val is equal to head dot next dot val, and also while head, of course, head equals head dot next. And then what we're going to do is we're going to return the delete self dot delete duplicates of head dot next. Okay. So this means else if, we're just going to return the self dot delete duplicates of head dot next. I believe that this is the code that works. Let's make sure that does. So we have head here, and what happens is that head and head.next are not the same. So that means we return the delete duplicates head.next. No, that's not what we return. We have to return the head. Well, head.next is equal to delete duplicates, and we need to return the head because the head is the item that does not move, right? Yeah, I think that's about right. Okay, so we have the head here. Head.next is equal to this next item. And this item is going to run the delete duplicates again and check if those items are the same. They're not the same. So we move head again. Okay. So head.next is going to point to delete duplicates of this item. Are they the same? They are the same. So head equals head.next because they're the same until they're done, until they're not the same. So head equals head.next. They're not the same anymore. And at this point, we're going to return self.duplicates head.next. Basically, we're going to skip all of these items like that. And now we have head here. We're pointing to head.next of this item. And this item, they are the same. So basically, we're going to move head forward. And we're going to point to head.next where there are no duplicates. And we have 1, 2, 5. All right, I think that works. Hopefully it does as my code suggests, and it does. Let's submit, and there might be issues. And there are. So what happened here was that we are getting the first item, and that is because we are returning head. Yeah. I'm not sure what to do here about the single item because we are returning head. And can we return self.duplicate? No. I don't actually know how to resolve this issue. How about head equals I'm gonna have to go look this up a little bit. Give me a moment. Okay, I think I have thought about it a little bit and I know what to do next. So what we're gonna do is take this input and test it out and see how we can properly do this. So we have our head here. And so this head and the head.next value, they are equal. And let's see what this code does for us. So head is equal to head.next. And we're going to keep moving until we return head.next delete duplicate. And what does that return? So we're going to return 2. And that's what was supposed to happen, right? But that did not happen. The reason why that did not happen, was it because of this? Why would this piece of code run? Well, this piece of code only runs until this part. It only runs until this section right here, where they no longer equal. And then we run this session. So basically, we have to make sure that only this part runs. So we do need an if head.val is equal to head.next.val. And if they are equal, then what will happen is that while this will run, we'll set that to next. And once that occurs, we're going to return this next item rather than going down to this layer here. I thought that my code already did that. Well, head.next, of course, while it exists. So I thought that this code does that already, but it does not. And the reason why it did not do what I was hoping it would do was because it broke out of the loop, right? It broke out of the loop and did not run my code when I wanted the code to run. Now that it does no longer, even after it breaks the loop, I do return the delete duplicates. Now I will return this line of code, which would delete the 111. All right. So let's review that and see how that works. So here is the head, and we're going to see that the next item is a 1, right? And so that means we're going to move the head until head.next. So now they are different, right? They are different. So when they are different, this no longer moves forward, and it pops out of the while loop. And then we return the delete duplicates.next, which basically means we're going to try to return this item without any of the previous items, okay? And now we can return the head 2 and 3 and 4. And now let's test the last item where we have 0 items, and that just basically returns the head, which is none. Okay, so with that, I think we can resolve this problem. I think I should have done something else, but oh, there it is. Okay, so with that, we have implemented recursively. This is the review. We have done that already. And the time complexity of this solution is going to be evaluate is the same. O of time is going to be O of n because we have to go through all n items. And the space is going to be O of n as well because of each layer that we delete. But apparently memory usage is even less than before for some reason. There must be something, maybe it's over 1. But supposedly based on the number of stacks it's O of n. But I think given what we know now, according to the memory usage, it is O of 1. Alright, if you have any questions, please comment below. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.